Okay, so in this assignment's all about CPCTC. A big phrase, so we shorten it. Corresponding parts of congruent triangles are congruent. So we have this story that we're telling about this famous long jumper. So I never heard of her, but if you are interested in athletic jumping for women's record holders, in 1983, this Heike Dressler, she could jump 23.4 feet. And the question is, can she jump BA? Could she jump over this pond this way? Or could she jump over the pond um, this way or this way? I guess there's three ways she could jump over the pond. The 15-foot, well, clearly she could jump this way. She could jump BC because she can jump 23.4 feet, and this is only 15. But what about these other two lengths? And we don't know right now. So one of the common ways that we use geometry in the world is like if I need to measure a distance over a lake, I would make a congruent triangle over the land, and then if I know that, I can measure that accurately, and then the one over the lake, if it's congruent, then I will know these other measurements. So let's see if we can show that these triangles are congruent. Now, one thing you notice right away is that these are right triangles. So you might be thinking, oh, I'm going to try hypotenuse leg because that's only for right triangles. But the problem here is that this hypotenuse, we know this one's 25, but we don't have any information on this one. So hypotenuse leg doesn't work. But we do know some other information. So we know that right angles are congruent. We can see that this side, 15 feet and 15 feet, so DC is congruent to BC. And we can also see that this angle in the center where they're connected, which is often the case because there's a vertical angle pair. And so angle DCE and angle BCA are congruent because they're vertical angles. Well, then we know by angle, side, angle, because that was one of our postulates. So triangle CDE is congruent to triangle CBA by angle, side, angle. So right now, what do we have here? We have the congruent triangle part. Okay. So remember, corresponding parts of congruent triangles are congruent. So right now we have the congruent triangles. So now we're going to identify the corresponding parts. And I can see that this length right here, this 25-foot length, is going to be this length. And so I know that EC is congruent to AC. Oops. To AC. So that so the distance is the same, right? EC is equal to AC, so this distance is 25 feet, right? Right. So could Helke jump that? No, she would get wet. So this it's too far. She can't jump that. And right now we're using the corresponding parts of the congruent triangles to show that they're congruent, so we can make this conclusion. All right, what about the other length, this AB? So let's use a different color for that. How about green? So AB is going to correspond to ED. So AB is congruent to ED. So that means the distance AB equals ED, and AB is equal to, or actually ED is equal to 20 feet. So yes, okay, she can jump this. So if for some reason this Helke girl had to jump over this pond, she would want to jump this way, AB. Okay, so we're asked to show that angle LKM, which is LKM, and angle JMK are congruent. So I'm gonna shade those in so that we can keep our eye on them. So I'm gonna make LKM is red, and JMK is going to be blue. All right. and this is angle J. All right. So what's our plan? So when you're going to show something, in math, of course, it means prove, and we're going to look at this picture and see what we can figure out. So I know that this angle L and angle J are congruent because it's marked in the picture and it says here. I also know that this shared side is in both triangles. So remember, it's in both triangles, so it's congruent to itself. So that works as in our favor. The other thing that I notice is that they tell us that these two lines, KJ and LM, are parallel. So that means that this angle right here, JKM and LMK, which I just marked in green, are congruent because they're alternate interior angles. So let's see if we can write this out. And the idea is that once I show that the two triangles are congruent, I can use the CPCTC, congruent parts of congruent triangles are congruent, and then make my claim that these two angles are the same. So here we go. So we're going to start with, we're going to say that angle L is congruent to angle J. How do we know that? They told us. So that was given. Right? What else do we know? Well, we know that KJ is parallel to LM. All right, so let's write that down. KJ is parallel to LM. Well, that was given to us. Right? Now, what does that mean? Okay, well, that implies something. That implies that the angles, actually, I'm not going to make my circle till later because I might run out of room. That implies that that angle JKM is congruent to angle LMK because alternate interior angles are congruent, right? And so now what we have so far is we have an angle, and the next thing we need is the side here. So we're going to use angle, side. And so the other piece of information we're going to say KM is congruent to MK. Now notice I'm going backwards there. I went KM forwards and then I went MK backwards. And the reason is because when I name these triangles, I'm going to say KLM, but then to match it up, I'm going to say MJK. And so they're going to be going this triangle is going to go KM, the other one's going to go MK. So let's write this down. Why is that true? That's the reflexive property of congruence. All right, so we have these three facts. So we have this angle, we have this angle, and then we have this side. And so I can say triangle KLM is going to be congruent to triangle MJK. I need a triangle symbol by angle, side. So angle, side. And then the last part is just to say what we wanted to show. So therefore, angle LKM is congruent to angle JMK by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so in this problem we have a rectangle, and our goal is to show that the two diagonals are the same length, that they're congruent. And so I want to show that this length is the same as this length. And you can see below I split it into two triangles. And so one triangle is going to be triangle IFH. The other triangle is going to be triangle IGH. And a lot of times that's very helpful when you have a picture like this. So I'm going to shade in the triangles a little bit so that you can see what I'm talking about. So this triangle FIH is this one. And the other one I'm going to make blue. So I'm just going to outline it here. And that's this one. So the plan is that if I can show that these two triangles are congruent triangles, then I can make the conclusion that this diagonal, this length FH, is congruent to length GH by corresponding parts of congruent triangles are congruent. So what do we know about these triangles right now? Well, I know that we have a congruent side on the bottom. So this has two tick marks on the bottom. It's the same side in both triangles. So that side IH will be congruent to side HI by the reflexive property of congruence because they're the same length. I also know that this length FI, or the side FI, is going to be congruent to side GH because you can see on the picture that this is a rectangle and they are marked congruent. We also know that in this triangle we have a right angle in each of these triangles, and we know right angles are always congruent. So that's the reasoning we're going to use. So we're going to say, okay, let's make our list. And so we're going to have side, angle, side, and let's just go in that order. So the first statement that we're going to say is we're going to say FI is congruent to GH, and that was given to us, but in the picture it's marked as congruent. What else do we know? Well, we know that angle I is congruent to angle H. Why? Because right angles are always congruent to each other. Right angles are congruent. So that's the second statement. The third statement that I need to talk about is this length here. And remember, that's the reflexive property of congruence, because in this picture, IH and HI are the same length. So we're going to say IH. And notice I've got to go backwards because remember, it's important the way we name these. And if I'm going from the right angle to this acute angle, I got to go from the right angle to the acute angle. So I'm going to say IH is congruent to HI, and that's by the reflexive property of congruence. So using these three things, they tell me that triangle FIH is congruent. So I went FIH, so I'm going to go GHI. It's congruent to triangle GHI. My G looks like a 6. All right. And based on that, I can make the conclusion that this third side here is going to be congruent. So now I can say, well, that means FH is going to be congruent to GI. Why? That's by CPCTC. Congruent parts or congruent triangles are congruent. Now it says the length, and remember when I write this congruent statement here and I say the line segment FH is congruent to the line segment GI, I might want to make the further statement here and just say FH, the length FH, the distance, is equal to the distance of GH, and that's by definition of congruent line segments. And that's our proof, our reasons why that's true. Now, one thing at the end here that I noticed I did not say is what was our reasoning for saying that these two triangles were congruent? And the reason was by side, angle, side. And we should have said that.